Today we're going to take a look at the relationship between mass and weight. We'll be changing the mass of our system by increasing the mass of our hanger and measuring the corresponding weight from the scale. If you have not filled out already, please fill out the title of the lab as mass, weight versus mass, and the purpose of our lab is to describe the relationship between weight and mass. You'll want to draw a physical setup that will look like the scale with the hanger and additional masses placed on it, and draw a force diagram for the hanger. Because we'll be changing the mass of our system, you're going to locate that or identify that as the independent variable, and we'll be measuring the weight from our scale. Now, all the scales we have in the class have pounds, newtons, or dynes as measurements of weight, but because all of the scales have newtons as a measurement of weight, we're going to use that. We'll get back to constant variables when we return to class. If you have not done so already, pause the video at this time and write a written hypothesis, a graphical hypothesis with weight on the y-axis and mass on the x-axis, and fill out your energy bar graphs before continuing. Also, before we start, it's important to take a look at the scale. Notice that on this side over here with newtons, the top right-hand side of the bar is at 0 newtons. We'll have to make sure that we're looking at that part of this movable bar when taking our measurements. From 0 to 1 newtons, there's 5 increments there. So we have to figure out what are each one of those small increments worth. Well, 1 divided by 5 is equal to 0.2, so let's see if this works. 0, 0.2, 0.4, 0.6, 0.8, 1.0 newtons. So each one of the small increments on this side are going to be worth 0.2 newtons. Now let's start gathering data. Notice when there's no mass on the scale, the corresponding weight is also 0 newtons. You're going to be wanting to write down the masses in a column measured in grams and have a second column of weight measured in newtons. We'll use a capital N for newtons. We'll now put the 50-gram hanger, on the scale. And with the 50-gram hanger on the scale, we look, and again, we have to look at the top right-hand corner of this movable bar. It's right between the second and third line below the 0. So the second line is 0.4 newtons, the third line is 0.6 newtons. What number falls between 0.4 and 0.6 newtons? 0.5 newtons is a good guess. Now we're going to add a 50-gram mass to our hanger, which makes the total mass of our hanger 100 grams. If we take a look up here, we're looking, and it looks like the top of the bar is just at the 1 newton, maybe it's a hint above. We'll say it's 1 newton at this time. We'll now add an additional 50-gram mass to the hanger. We now will have 150 grams on our hanger. When we take a look at that, it's again between 1.4 and 1.6, but it definitely looks like it's a little closer to 1.4. So maybe we can record 1.45 newtons. At this time, we're going to go from a 150-gram hanger to a 200-gram hanger. So I removed a 50 and I'm going to add a 100. Now we've got a 50-gram hanger, a 50-gram mass, and a 100-gram mass. So our total mass is 200 grams. And now you can see that it's clearly just above the 2. So let's guess at about 1.9 newtons. We'll add an additional 50 grams. So the mass of our hanger is now 250 grams. And it looks like we're at about 2.45 or 2.5 newtons on the scale. And from 250 newtons, we're going to go ahead and jump up to 350 newtons. I'm adding another 100 grams down here. And now we're at about 3.5 newtons is our weight. We'll add one more 100, so now we're at 450 grams. And the corresponding weight looks like it's approximately 4.5 newtons. Please use this data to fill in the Google spreadsheet shared with you on Google Classroom, where you're going to make a weight versus mass graph. it will be important that you take the masses that we've recorded here in grams and convert them to kilograms in the second column, because when we build the graph of weight versus mass, we'll want the weight in newtons and the mass in kilograms. Do you remember how many grams are in a kilogram? If not, look it up. I hope that helps.